Hello everyone, in this lecture we'll talk about graph minor and graph transpose. These are operations that we can do or perform on a graph in order to get a new graph. So we'll start with the last one, graph transpose. What is a graph transpose? Sometimes it's called converse or reverse. Well, basically a graph transpose of a directed graph is the same graph but with all its edges reversed. So graph transpose is only for directed graphs, and basically what we do is we don't delete or add any vertices, we don't delete or add any edges, but basically what we do, we reverse the direction of all the edges to the opposite direction. That is basically graph transpose or graph converse or reverse. So let me give you an example. Let's say we have a graph like this. As you can see it, this is a directed graph because it has edges that have directions. So for example, this is right here, it has a direction from D to A. Graph transpose of graph X right here is a graph with edges having opposite directions. So this is a graph transpose of X. As you can see it, all the edges have opposite directions. This is the original one. This is the graph transpose of X. So basically a graph transpose or reverse or converse of a directed graph is the same graph but with all its edges reversed. That is graph transpose. Then we come to graph minor. Graph minor is an undirected new graph H obtained by deleting edges and vertices and by contracting edges of another undirected graph. So when we have a graph and we perform deleting edges and vertices and contracting edges on this particular graph, we get a new graph H that we call it a graph minor. So let me give you examples. So let's say I have this graph, I call it G. In order to get a graph minor, I can perform deleting and contracting edges and deleting isolated vertices. That is what I can do. So basically on my graph G, I will delete the dotted edges and I will contract the red edge in order to get a new graph. So let's do that. Well, I will delete those edges and I will contract the red edge to get a new graph H, which is a minor of G. So as you can see it, our graph was like this. This is graph G. However, we performed deleting and contracting edges in order to get graph H, which is now a minor of G. That is basically a graph minor, which is obtained by deleting and contracting edges and deleting isolated vertices. So let's do another example. Let's say I have this graph and I want to get a graph minor of G. So I will delete and contract edges and I will see if I have any isolated vertices in order to delete them in order to get a graph minor. So what I do is I will delete the dotted edges. I'll contract these two edges together in order to get a new graph. And when we do that, that is the dotted edges deleted. We get a vertex that is isolated. We will delete that and we will contract the red edges in order to get a new graph H, which is a minor of G. So as you can see it, this was our graph G and we got a new graph which is the minor of G, and we got the graph H by deleting and contracting edges and deleting isolated vertices. That is the basic idea of graph minor. So to loop back in, a graph transpose or converse or reverse of a directed graph is the same graph but with all its edges reversed. What we do is we reverse all the edges to the opposite direction and we get the transpose of that particular graph. Graph minor is an undirected new graph H obtained by deleting edges and vertices and by contracting edges of another undirected graph G. And that's it about this lecture.